Ohmic and Non-Ohmic Conductors. To understand the difference between ohmic and non-ohmic conductors, let us perform another activity. We have a circuit that has an ammeter, a plug key, and a DC power supply. A nichrome wire and a torch bulb are fixed on a separate wooden board as shown. We now connect the ends of the nichrome wire to the circuit. A voltmeter is also connected across the ends of the wire. When the key is plugged in, the ammeter gives the value of the current flowing through the circuit. The voltmeter measures the potential difference across the nichrome wire. Let us now increase the supply voltage and record the values of current for different values of voltage. As expected, the ratio of V to I is constant for all the cases. If we plot this relationship on a graph with voltage on the y-axis and current on the x-axis, we get a straight line. The ratio of voltage to current is constant over a range of voltage and current. In other words, the resistance is constant. Such conductors that obey Ohm's law are called ohmic conductors. In ohmic conductors, the relationship between applied voltage and current flow is linear. Let us now remove the nichrome wire and connect the torch bulb to the circuit. Since the resistance of the torch bulb will be higher than that of the wire, we start with a higher value of voltage so that the current is measurable. As soon as the key is plugged in, the ammeter shows a deflection that gives the value of the current flowing through the circuit. Note that this reading is different from the ammeter reading for the nichrome wire. Different conductors have different values of resistance, and hence, the current flowing through them will be different for a given value of voltage. Let us increase the supply of voltage gradually and note down the values of current. As we can see, the current increases with increase in voltage, but is this increase linear? If we calculate the ratio of V to I, we find that this ratio is not constant. Why does this happen? Well, the filament of the bulb warms up when it is turned on. Its temperature increases dramatically. When the voltage is increased, the resulting increase in current heats up the filament further. With this increase in temperature, the resistance of the filament also increases. This resistance limits the flow of current, and hence the current does not increase proportionately. If we plot this relationship with voltage on the y-axis and current on the x-axis, we do not get a straight line. This shows that the ratio of voltage to current is not constant. In other words, the resistance is not constant. Such conductors that do not obey Ohm's law are called non-ohmic conductors. Other non-ohmic conductors are semiconductor diodes and transistors that are used in computers, cell phones, and other electronic devices.
Starting to feel it? Now go master it with maskitv.